looking at how that change might impact something else in the design. Maybe it impacts the packaging. Maybe it impacts the the usability. Maybe you have to go back, if it's a big enough change, go back to the end user. We made this change, and they will bless it or not bless it for you. And then this reason for the change and any other testing that you had to do to go back through the V&V process, all that ends up in the design history file. Why do we need to do all this? That's probably how most people view design control, including risk management, because it just seems like an overwhelming amount of documentation. Perhaps, but who in here has lived through a 483 from the FDA? Form 483. A couple people have had that pain. Anybody lived through a warning letter? Huh? A couple people have had that pain. Go on FDA's site and just do a search in the database. They have a warning letter database. And so obviously this changes by the day, but I just type in the design controls. 506 citations in warning letters specifically to design control. CFR 820.30. It is consistently in the top 3 citations from year to year. And it's the #1 citation in the Dallas district, which happens to be our district. Design control is really, these regulations have only been around about 20 years, so relatively new overall, but there's a whole packet on how the inspector needs to come in and look at your design controls. Who's lived through a recall? You're the luckiest guy. You've seen it all. This is one example, trying to protect the innocent company that recently had to recall 200,000 infusion pumps. They had to destroy all of them. There was no mitigation. They needed to be recalled, destroyed. There's no rework, nothing. And that is because this particular company had really not taken the FDA's warnings very seriously. And so they just had a poor reputation of fixing. So the FDA says, not an option. Just need you to pull them all. $400 to $600 million was the cost that they had to cover that recall. So that's one thing that might influence you to want to do design controls. What's a little paperwork? You can look at design flaws versus manufacturing flaws. A little bit different. So the design flaw, that hazard's there from the beginning. You designed it in. Probably not on purpose, but you didn't catch it somewhere along the way. Didn't find it or didn't choose to fix it, didn't think it was going to be that big of a deal. And that type of a recall may affect every unit made because it's in the design. Okay? A manufacturing flaw, a little different. The hazard is created maybe during the assembly process. Typically you can fix it, making some changes on the assembly line or to work instructions or to something there. And perhaps that's recalled to or contained to just one group of units from that manufacturing site or from that month when something new got installed on that line. You can sometimes contain it. Okay, so that's why we really want to focus back on the design piece. Just a couple of quotes in here just kind of show this is, Bruno Gries did a dissertation in Belgium, I think, about feedback in the product development cycle. 80% of all quality problems have their root in design, development, and planning. And he wasn't the only one that thought that. Bruno had also developed this chart, and sorry about the wavy line, that was my freehand. You can see design and development. Here are cost per failure times 10, times 10, times 10. So as you're going further and further in the process, it's going to cost you a lot more to go back and fix something. So It's a lot of paperwork, it's a lot of time, but we're probably going to get something much better on the other end. In the FTA's design control guidance documentation, it's a well-established fact that cost to correct errors is lower when they're detected early in the process. That's common sense. And a recent ASQ article, Randall Gooden said, in my ongoing analysis of product recalls, find most are due to defects in design. So this is pretty common knowledge out there. The QSR, there's a preamble in that, and for those of you in device, if you're not using the preamble, that's probably the most powerful part of the quality system regulation. It tells you why they did what they did, what was their thinking in putting those regulations in place. And in that, 44% of quality problems leading to recall could have been prevented with adequate design controls, and 90% in the software. So look at 3 cases. How much time? I'm good? Okay, just go like this. 3 cases of things that didn't go quite right. First one was a pacemaker. And in this particular one, if you press the on button and one other key randomly while it's in self-test mode, shuts the device down, won't work, displays an error code, but you cannot turn the device off. You can't turn it off and reset it. You can push all buttons and it's just there. What you have to do is you have to open the battery drawer and put the battery drawer back in, press on, and then the device will reset. None of this information is in the troubleshooting guide, but it is in the engineering manual. So when you send it back, the engineers know how to reset it. But if you're in the midst of trying to do something with pacemaker, usually you pretty much need to do it right now. So having a process, they had to go and get a second one, and it's maybe not real common that you would be pushing on and this other, but you got to imagine the environments you're in. Very hectic, things are kind of crazy, people are, doing all kinds of things and grabbing. Well, this should not have been designed this way. They knew it because they had a way to fix it in their engineering manual. This one I referred to a little bit as an insulin pen, and you dial it at the end of the pen, okay? So not the glucose meter, but the actual insulin injection. Dial it at the end, and it'll say, in digital readout, say 25. Well, if you're left-handed, you might be dialing it. It's going to say 52 for 25. And so you have to understand they're either going to deliver too much or too little insulin. If they're a left-handed person and they're not realizing that pen has to go that way. Okay? They chose to mitigate this with literature. This is a pretty big deal, though, if you're the one involved in it. And lastly, this is a cardioversion case. A healthy male comes into ED, emergency department. He's got chest pain. They do the cardioversion, shocking, and it's refractory. Not getting a good response. So they crank it up, shocking a second time, goes into a VFib arrest. Work on it for 45 minutes, patient dies. So they go back and look at the summary, and they reveal that the nurse failed to put the device in the sync mode for the second shock. So there's a default setting. After you shock, it doesn't go to the sync mode. You got to put it in sync mode in order to do your second shock. There's no feedback that tells you this. There's no warning, there's no alarm, there's no, hey, do you know you're not in sync? No voice, nothing. So a lot of the cardioversion, they're different. Some do this, some automatically reset to sync. So you're in a hospital environment, you're in an emergency situation, you're trying to resuscitate a patient, you don't really want to stop and go, now is this the one where I have to go in and push the button to resync it, No time to read the manual when your patient is here in VFib, exactly. So these are just a couple of examples that seem really